just a quick introduction as to what we are doing as a panel. So myself, my areas of interest are more aligned with multidisciplinary big data applications, doing AI, explainable AI, especially in drug discovery, computational drug discovery, human AI evolutionary systems, autonomous systems interactions. How can we explain the system better to help the user understand why the AI made the decision as it did, and how can we improve the human AI trust, how can we improve the adoption, and at the end of the day, how can we make the users more friendlier, towards adoption of technology as a whole. So that is basically what I do, and I'll pass it on to my colleagues here. Lisa?
Thank you so much, Dr. Menon. My name is Dr. Lisa Vangsness. I am the lead investigator, the head of the Challenge Metacognition and Perception Lab at the University of Alabama in Huntsville. And that sounds like a mouthful, but really when I think about what I like to do in my lab, I think about the process of translation. So we're all human beings, and we're trying to understand what the autonomous and artificially intelligent systems around us are saying to us. Sometimes we want to know whether something was produced by AI. Other times we want to know what kinds of choices AI or autonomous systems are making and why. Sometimes we want to know whether we should follow those choices or not, or whether we should even adopt a particular kind of technology. So my laboratory, in a very simple sense, we specialize in helping the people who are designing those systems create designs that support the human understanding of those systems. But likewise, we also work to help AI systems and autonomous systems understand, that's in big air quotes, understand the human being. So if I need to model a human being so that an autonomous system understands that human state, what kinds of variables do I collect? What's important in that process? And of course, as humans, that's something that happens very naturally between us. I can tell whether you're paying attention to our panel or not. I can tell whether this topic is interesting or no, right? But when we're talking about AI and human beings, we have to be much more intentional in how we go about that process. So in a nutshell, that's what we do. We're helping people design those systems. We're learning more about how the systems work, and we're developing the tools that help improve and facilitate that translation process.
Okay, that's my turn now. So my name is Anna Wooley, and I'm an assistant professor at UAH. I just joined our department, the ISIM department, Industrial and Systems Engineering and Engineering Management. And my whole background is in industrial engineering. And I did my master's, undergraduate, and PhD, and got my PhD last year. So, and when I joined UAH. So I've been my focus on research is related to manufacturing specifically, because that's kind of what my background, my passion is, but is the adoption and the understanding of what the digital twin systems are, and how do we make a comparison between what is a digital twin and what are the other technologies, what are those components of digital twin, how do they treat individually, how are they work together. My biggest contribution as PhD dissertation-wise was to provide that comparison between simulations and digital twins, since they seem to be very confusing and a lot of people get that the other way around. So I will talk a little bit about here today and how does AI go in, play in that area. So that's all for me.
Yeah, my name is Howard Chen. I am also faculty in Industrial and Systems Engineering and Engineering Management. Joined the university exactly 2 years ago. So I found and direct the Chartered Robotics and Biomechanics Lab. So we focus broadly on robotics and biomechanics, as the name implies. But what we really work on is motion sensing, motion tracking, and also computer vision. And then more or less try and develop and apply these technologies towards understanding biomechanical human movement, as well as to improve autonomous vehicle capabilities. So for a lot of what we do within all of this is we leverage AI technologies for all of this, and we also, develop algorithms to try and make AI better as well.
Thanks, Howard. So as you already have kind of got a glimpse into our expertise, this panel is going to be delving deep on assessments on human AI technology from systems perspective, from robotics, digital twins, psychology, and computer science. And most of the discussion here is going to be centered around why we need to open the floor over here for discussing like-minded ideas, designs, methodologies for better assessment of human AI systems, right? We no longer live in a world where we can silo and say, this is my place, this is my idea, and this is my design. To make it applicable to human AI, we need to talk across the board, and that's what we're going to be doing today. So a lot of discussion topics, recurring themes are going to be around virtual environments, how do we map it to real world, human AI studies, digital twins, and most importantly, a holistic method for having AI systems, psychology modeling expertise that we uniquely possess in this university. And all the fun projects that we get to do with DoD-funded research. So round one, guys, I want to have a little bit more deep dive into individual backgrounds, right? So Lisa, starting with you, can you shed a little bit more light on how you can ensure from a psychology perspective that humans and AI can understand each other and they're doing the right thing when it comes to accomplishing task or mission, whatever you're designing your systems for?
Yeah, absolutely. Thanks so much, Vineetha. So as Vineetha mentioned, as Dr. Menon mentioned, I'm a psychologist by training, and usually when I tell people that at a dinner party, their first thought is either that they don't want to talk to me anymore because they're afraid that I'm psychoanalyzing them, or they want to tell me all of their childhood experiences with the people that they didn't like. And I always have to take them a step back and calmly explain to them that I'm not that kind of a psychologist, which strikes people in an unusual way, right? Because people are like, oh, well, psychology, that's about my history and my behavior and my attitudes and beliefs. And I'm like, yes, it's all of those things. But some of us understand or seek to understand how those things inform your behaviors in your life as they relate to the ways that you engage with other people, your goals, etc. And others of us try to understand how that relates to the ways that you, say, interact with technologies. So I know things about how the brain works, about how people perceive the world around them, how they think about things. And that allows us to issue design improvements to the products and technologies that currently are out there in the world, but it also allows us to design better technologies for the future. So, when I think about the process of helping humans and AI understand one another, I'm really thinking about that on a very granular level. And I usually take it back to human-human interactions. Because humans are incredibly skilled at being able to understand one another. You all can look at me and get a feel for how comfortable I am in this environment. I can be looking at each of you and making inferences about your behavior and how you may be receiving my talk. And these are things that occur without us even thinking about them, based on small, subtle pieces of information, we'd call these cues, that we're all giving off through our behaviors, the ways that we're acting, etc., or through the things that we're saying, right? And so part of what my lab does is we identify what those different behaviors, things people are saying, etc., which of those are relevant to the performance outcome that we're trying to optimize within the context of this environment. What is the human AI or the human autonomous system's goal, and which behaviors are relevant in the pursuit of that goal from the human side? But also, what pieces of information is the human going to want to know about that autonomous system? So a lot of what we do as a lab is I get to work with these fabulous people over here and other people at the University of Alabama in Huntsville. And we get to go in and learn about the kinds of systems that they're designing. An augmented reality space for finding hostages, or an augmented reality space for being able to quickly evaluate what kind of medical attention people need on a helicopter. And in each of those situations, the question is always, what information does the human need to make a good choice? And how do we display that information to the human effectively? And likewise, What information do we need to know about the humans involved, and how do we code that into the technology? Of course, that's not the part that I work on. So my lab has done some work relating to what we call the metacognition of human AI teams. It's just a fancy psychology word to say how I understand the current state of an AI system or an autonomous system. Do I think it's making good decisions or not? What pieces of information do I use to decide whether to trust or not to trust that artificially intelligent system? And what that system looks like could be many different things. It's usually whatever these people are working on at a given moment. But we also develop tools to help AI understand humans. So right now, one of the things that I've been working on in my lab is finding ways to use, I'm going to get technical for a minute here, the embedding space of a chat-based AI tool to be able to draw out sentiments in the context of a human sentence. So basically what that means is that if I say a sentence, an AI tool is going to translate that into a string of numbers. Those numbers are a vector, a list of numbers, and they all represent different things. If I know how the human felt about that sentence that they've said, so I might ask you to say, rate the difficulty of this task on a scale from 1 to 7. And then I could say, why did you say it was that difficult? That sentence that describes their difficulty rating, I can convert into an embedding vector. And based on that information, I can create a predictive model that allows me to, in a single sentence, out of sample, automatically know how difficult a person thought that thing was in a given moment. So we now have a real-time measure based on words of how a person felt in a given second. And we call this the linguistic fingerprint. It's a patent-pending tool. And we figured out how to make it work, and we validated it under a number of different circumstances. And that's a really powerful tool because it allows us to get that state measure of what a human is doing. What's their workload in a given moment? How much do they trust the system? Was this task hard for them or not? Do they need additional assistance? If we can quantify that readily, now we can create a system that responds to that. And those are the kinds of systems that my folks in engineering and computer science are asking for. So those are the kinds of tools that we're delivering.
That's cool, Lisa. Just to add the emphasis of why we need to have psychologists in the team and to expand on one of the scenarios from computer science side, we do have a lot of virtual environment modeling, real-world modelings that we do and build AI tools for example, AI on the drone, for target detection in the environment, for hostage rescue, for example, for explaining why it is important. And to give a case in point, this was an interesting study. This was done, this work actually started about 5 years ago, and we had a virtual environment for hostage rescue. So basically, we had a drone, and it was an autonomous drone, AI loaded on the drone, and the drone would fly in the environment and do what I like to say, targeted identification. So it goes there and finds where the rescues or the hostages to be rescued are, and it's going to inform a small map to the user saying, hey, here are the people you want to go, and here is the exact location where they're located in the environment. So I, as a soldier, don't have to go and scramble around and figure out who I should rescue and where they are located. Now the drone is going to tell me exactly, go to this position, right? Because in dynamic environments, we don't know what's out there, and knowing that information beforehand is basically leveraging the power of autonomous systems and AI. Now let's take it a step further. This sounds cool. AI is going to fly out there, the AI-driven drone is going to fly out there, tell us where the hostages are located, will help me do what I call targeted rescue later on when soldiers are on the ground. Sounds great. But when we did the second round of study, which is actually saying, okay, let's do a control group where you do not have access to AI, and this is a sophisticated environment with mountains and hills and trailers, and you have to go and explore physically, right? But I mean, physically, you really have to walk through the environment. So if you do not have AI, it takes a bit of time to figure out where people are. And then you add the automation, let's see how much performance improves. And now let's add another layer of complexity saying, okay, AI, now you not only tell me where people are located, tell me what is the best way, the optimal path to go around to rescue these people. Right? Wouldn't that be great? Because now I know exactly how to move from location A to location B and exactly which path to follow to, number one, optimize my mission and complete my mission. Right. As computer science, it made sense to me when I was designing that this is the best way to go. But when we brought people in, the results were mind-boggling because people do not think like machines, right? And we design technology for working with human beings. So for example, when we brought people in for the control group without the autonomous systems, and we told them what the experiment was about. However, there were people who trusted technology and who did not trust technology. Right? So people who did not have access to autonomous system decided, okay, I'm going to go and rescue however I want, and I'll choose the path depending on my expertise however I want. And the people who had autonomous system, again, we found a lot of deviation between so-called optimized path by AI and what humans chose. Number one being personal motivations, right? So let's say if I'm incentivizing the number of people you rescue to complete your task, it makes sense that I want to rescue as many people as possible. I want to save as many people as possible. And now as a person, you have motivations, moral implications. For example, I would say, I want to go to the nearest house or trailer where I find a person to rescue first. That's a different starting point and path. Right? If somebody else has a personal motivation saying, I don't mind going the extra distance if I can save many people. So there are 3 people located in this house somewhere, I'm going to go there first. Now that becomes a different starting point, a different path, right? So when I say the AI, give me an optimized path, it is not considering all of these psychological constraints and values and morals we have as human beings, or even our domain expertise. So the final map we got, was completely different than what AI told us. Some of them follow the optimal one, but some of them did not. And that is what got us down this train of how can we bring what AI thinks together with what human beings think and find this soft ground, middle ground, where we can optimize the decision making to complete whatever task we're doing. So most importantly, you cannot simply think, let's look at AI and decide what the machine is doing and just follow that blindly. At the end of the day, machines are made for the human beings. AI is made for the human beings, designed for the human beings, and that is exactly where expertise of these individual fields come in. So Howard, I want you to take this a step further. So can you talk about how you're using AI currently in your research, in autonomous systems? You got cool drones, robotics going on in your lab. You worked on GPS-denied environments and stuff like that. So can you shed a little bit light more on, those kind of AI-related research you've got going on?
So, that's an excellent question, Vineetha. There's a few ways that we use AI in my lab. A lot of what we do right now is computer vision related. We do some work with human motion tracking, and for a lot of that is we are leveraging the latest and greatest what we call markerless motion tracking technology. So you have a camera pointed at a person. It could be a video on YouTube, for example, and then you could superimpose the skeleton of the person and then figure out where the person's joint position is. And so we could take that data and use it to we have projects trying to use that data to understand fall risk of the elderly, but we could, use that information just as readily to understand, what a person might do next. Is that person, friend or foe based on the action of their movements? So there's lots of uses for it. We also use AI, ML for general object detection and tracking. So we leverage you only look once models, for example. We take the models and we train with our own data. So we are using that primarily to improve navigation solutions. So if we have a swarm of quadcopters, for example, and the cameras are able to recognize where each of the quadcopters are within the swarm, then we are able to leverage all the information from each one of the drones together to hopefully get a more accurate navigation solution than what it could do by itself. So for those 2 projects, mainly we treat AI/ML as a black box, and we use a tool to advance some underlying research questions. But at the same time, we also have some other projects in the lab that we are actively developing AI for. So where we are working in the area is in terms of signal processing. So using your classical statistical-based methods, we can only go so far. And there's nuances within the data that we, as people, may not be able to recognize. So we use what we call inertial measurement units. So these are your gyroscope accelerometers that is central to any modern day navigation system. And the way that we have been treating these sources of information so far is as using physics-based models, differential equations. And lately there are more and more AI-based methods that says, hey, if you take these data, feed it through an AI, without using any additional information, we could figure out where you are more accurately than using your classical differential equations. So we are just started working on this project a few weeks ago. So our results are still to be determined. And one thing with all of this is that we forget when we work with AI is just the amount of data that we need, the amount of data that I had to go and collect myself. It's not only time consuming, but also very expensive to do so. So for some of the machine learning, detection work that we've been doing, it took probably 3-6 months for our guys to get our robotic platforms to the point that we are able to collect the data that we need. In our case, training of the data, just took overnight on a computer. We didn't have that much data. But it took months for us to get our robotics platform to be in a place for us to get the data that we need.
Thank you, Howard. And just to give you guys a realistic perspective, 4 years ago, when we started doing a lot of modeling, we had to consider real-world applications, make sure data complies to the rules, and consider the shadow effects, lighting, rotation, all kinds of stuff, do data augmentation ourselves. When I mean ourselves, you delegate it to your grad students, of course, for doing the data labeling. And it pretty much took them the entire summer to do hand labeling of 10,000, 20,000 images. And now we have AI that can replace a lot of that automation. Of course, there's nuances to that because you can have a labeling that is done wrong, and we're always doing automated labeling for Big Daddy Google. Every time we want to give any authentication, hey, select the lights or randomize zebra paths or do this rotation stuff to make sure things comply. That's where all the data crowdsourcing labeling information goes. So data labeling is still a huge issue in machine learning. So Anna, can you share a little bit more about how AI factors into your digital twin research and how it is revolutionizing how we look at the world today in manufacturing and systems? Thanks.
Yes. So I don't know if everybody here is familiar with digital twins, so I'll give you a brief overview of what that is before we get going into talking about it. But if you think of it as, in brief words, just a physical system, 3 components: physical system, virtual system, and bidirectional data between the two. So you have a physical system, you have data and information feeding a virtual system that is replicating what that physical system is, but at the same time you're supposed to also have that data feed back to the physical system and use that information to make decisions. And overall, at the end of the day, it's all about using that to aid decision making and make those decisions that are on time, they're live, and they can be done right now instead of making decisions based on historical events, on previous analysis, or so other characteristics. So when you say that definition and you think about digital twin is a virtual representation of a physical system, isn't a simulation model a virtual representation of a physical system? Isn't a CAD model a virtual representation of a physical system? So that's how it gets so confusing that you see a lot of people calling a CAD model a digital twin or so many other the other day I just heard, I'm trying to write a paper on differentiating control systems in digital twins. I've done a simulation in digital twins. So it's just, the digital twin, it's a more, if you think of a system, it's more, all of these things are components of a digital twin. So you use that digital twin as that virtual replica so you can test decisions and make decisions that you can go to the physical system and you know that could happen. And it's not one model of a system and then that's it. It's more like a VIN number. It's a model of one car and how that car behaves in that temperature, in that day, in that format, and whatever. So AI, if you read any research on digital twins, there's always AI ML mentioned in there. And there are several definitions and frameworks on how to build a digital twin on capabilities-wise. But one of the capabilities, digital twins are used. Why do you want to have live data and monitor and have that physical virtual system of a physical? Because one, you want to test scenarios that you don't want to test in real person, because first, you don't even have that to be testing, or you don't have the resources to test in physical, so you want to test that in virtual. Other one is for you to monitor what's happening now, so that's what that live data component is important. But also not only monitor, but also to be able to make decisions and have the autonomous component that you can either aid the human in the loop making decisions or make the decision by itself. So from the research that we see, at least in the academia world, we don't see a lot of digital twins applications doing all of that. So we only see when they reach only a few capabilities, they're able to set up a virtual of a physical that is monitoring the system, is receiving live information, it's collecting, it has AI and ML behind things, either to help optimize decisions there, either to help collect, help track systems and help you collect those historical and continuous live data feeding to let you know when are things behaving when they should not be behaving like that. So you can go ahead and simulate that scenario and know that like in 30 minutes, if this continues behaving like it is, it's gonna break down and cause all this stress in my manufacturing facility. So what can I do now to prevent that 30 minutes in the future to happen? So it's a more alive decision making, and that's what the AI is important there. But we don't see yet a lot of applications of it being a complete autonomous, because also that comes into the trust, how to even trust that digital twin making decisions for you. And one way to even know what is the fidelity that you need to have, and at any other type of model, you need to determine what is the goal you're trying to achieve there, because you can't just, Dr. Thomas in our department says that all models, all models are wrong. What's that?
All models are inaccurate, but some are useful.
Yeah, all models are wrong, but some are useful. So how much fidelity do you need to solve what problem? Do you want to just monitor what's happening so you can make a live decision right then? So do you even need to achieve all these autonomous capabilities if you're not even going to use it? So those decisions is what we're trying at UAH there to try to research that and push a little bit of the boundary there in the knowledge.
Thank you, Anna. That was great. So I'm going to use Anna's answer to help you kind of shed a little bit more light, Lisa, on how do virtual environment test beds kind of mirror the physical environment, and what are your design constraints or thought process that you consider when you do any such modeling?
Wow, goodness, that's a very broad question. I love it though. Okay, how do virtual environments mirror the physical environment, and what are the considerations that we need for that? On the surface, if we're modeling something in a virtual environment, there are certain things from a human factors perspective that we're going to be able to test and other things that we can't, right? So if we're creating an augmented reality mock-up of the interior of a helicopter and you're flying the helicopter using this augmented reality, all of those physical components of the helicopter aren't going to be there. So any kind of assessment that we might need to do with something physical, we'd probably want to do in a physical space rather than through an augmented reality space if what we're concerned about is how people tactilely assess those buttons. That seems really silly, but if you think about, like, I don't know, you're testing out a new pair of flight gloves or something like that, and you need to know whether they issue enough dexterity for someone to be able to fly an aircraft, that matters a whole lot. And we wouldn't necessarily want to do that kind of testing in a virtual environment. But if we're thinking about things like a person's cognition within that context, how they're thinking, what they're thinking about, what kinds of actions are going to come from that thought process, if we're thinking about their perception, where they're looking, how they're thinking, we absolutely could do that kind of testing in an augmented reality environment. And my guess is that it would probably have a high fidelity with what's present in the virtual environment, because the differences that we see across those two scenarios aren't great enough, they don't, to impact that outcome. We're not dealing with a physical dexterity issue, we're dealing with something like cognition. So as long as you're representing that physical space in augmented reality at a high enough fidelity, you're going to end up with assessments that mirror that kind of a context. So I think the things that are going to be most relevant to include in that augmented reality environment are going to be related to the key outcomes that you're focusing on. Do you want to know how quickly people navigate through a particular environment? Then you're going to want to give them the capability to navigate within that context, and you're going to want to give them the pieces of information that they would be using in the physical space to perform that navigation. Whereas if you're concerned with how they might be organizing and sorting through information in that environment, like say I have menus about a person that I've come across and I need to be able to move through those menus to better assess that person's situation, in that case, we would want to provide people with the information about the architecture of that scenario, the information architecture. I don't know if that made sense, information architecture, but that's kind of the thought process that I'm thinking of, Vineetha.
Great, thank you, Lisa. So Howard, can you extend your insights from the virtual environments, and what are the difficulties you've faced in designing the practical constraints, be it data collection, robotics, physical obstacles that you have to navigate, and how do you integrate AI in human systems research to make sure it's valid both in physical and virtual environments?
Oof, lots of questions boiled into one question. I think where I would probably start with trying to answer is how do I better leverage virtual reality in terms of what I do. And to put it bluntly, I haven't really leveraged virtual reality much in terms of what I do, but going forward is obviously a very important tool. If you have followed self-driving research through Google, they've always talked about the millions of physical miles driven and the orders of magnitude more in terms of miles driven virtually. There's always going to be edge cases that we cannot test in the real world. Just won't happen. For example, we're not so virtual reality is very good for that. There are there's also just if we do things virtually, there's generally speaking, there's a ground truth that we could definitely use. The hard part is what we call the sim to real transfer problem. So how much does simulation reflect reality? And also, can we use simulation to get our model probably 89% of the way there, and therefore we could get a really high fidelity model going with perhaps using far less training data. I guess kind of going through that thought is we've also developed a lot of technologies in my lab towards auto labeling data for to train our various algorithms. For example, we have a optical motion capture system, and so we could put reflective markers on any object within our lab space, and we can measure its position and orientation to a very high degree of accuracy. So we put 3 of these markers on our robot. We drive it around. We have a relatively simple model of our camera, how it behaves, and so we use that to do auto labeling on our data for training some of the models that we use. Thinking about motion capture, for example, a big thing that big limitation with motion capture is the fact that each marker needs to be seen by multiple cameras, or else we lose track of it. This goes into the importance is more trying to train your markerless motion capture algorithms up, for example. So we've developed some algorithms that combines that with wearable sensors to make sure that our cameras are tracking the objects correctly. And hopefully that allows us to get truth data a lot quicker. So I think there's kind of 2 aspects to the how we get data to train our algorithms, right? There is, well, how do we leverage virtual reality to do so, and the problems associated with it, and how can we also be smart in terms of how we collect our data.
Thank you, Howard. Just to quickly add, virtual environments are great for proof of concept study to see if the idea is panning out as you desired before you implement it in practice, right? So like the hostage rescue, when we designed it from a computer science perspective, oh, I got the best AI algorithm. It's doing a 100% detection job of hostages. Great. It tells me which way to go, path planning. Awesome, check. But then when you brought humans back to the picture, well, humans decided to do whatever they wanted to do and not what the system wanted them to do, right? So we are motivated intrinsically by our models, philosophies, decision-making is quite geared depending on your years of experience, dynamic versus static environment. So it's really great to have virtual environments in place to say, I'm going to make a specific modification and see if this is going to help you make your decision better. Right? So if I want to do, for example, add explainability, which is what we did then, we said, you know what, maybe there's a disconnect between what the AI is doing and what people want to do in this environment. So if I explain to you what was the motivation behind AI coming to the specific decision, be it identification of hostages or priority of rescues, would you be more likely to follow the AI's decision? Or would you be more open to considering making decision X over decision Y? What is that additional information that we can give you so you can make better informed decisions in any kind of task-based, mission-based scenarios? Which is great. But if I do not know what the outcome is going to be, or if there is any unintended behaviors, either from AI, emergent behaviors, or on the human side, implementing directly in practice is going to cost us a lot, especially in the field. So this is exactly where virtual environments are just perfect for that. However, we also should realize that having this real-world practical consideration of this is going to be applicable to a human being, a human is going to adopt this, and what can we do to make this conversation easy by having the human domain expert come in and sit in and look at this environment and say, if this is what you want, what can we add to make it better for you? Is this something you would be willing to work with? That kind of open conversation is going to be most pivotal to making sure any kind of technology is adopted. And I just want to quickly toss in that, yeah, physical environments, having domain experts is good, but at the same time, we want to make sure that we are not overwhelming the people with a lot of AI-based information. And that is one thing we also try to work with at UAH, across the fields. We want to ensure that we are cognizant of the cognitive load we impose on the human beings while we come up with this fancy stuff. So I can have a complex environment, you have drone, you have decision-making, things are moving around, you have adversaries in the environment, and I'm explaining every damn thing I see. How well do you think you will be able to manage all that information coming in from AI? Is just trying to help you. But do you really need that much of help in the moment to make the decisions, right? So how much help is too much and how much is just right? And that's also a really good question to navigate and discuss and understand. Are we giving you the right kind of information to empower you to make the decision, or are we overloading you with information where you're completely blindsided, adding extra cognitive stress, and it is not helping anybody than just showing off, hey, I can do cool things with AI, right? So that is a really delicate balance we have to work with on a daily basis, and hence I get to work with awesome colleagues who tell me, hey, don't get, too ego overwhelmed with the numbers, and try and talk to real people and systems to figure out what works and what doesn't work. So Anna, tell me more about digital twins, and how does validation and any kind of key metric and assessment come into play while you're trying to understand AI performance in digital twins?
Yes, when you're trying to create that virtual setup of a physical system, you can't create of every single variable. So you need to determine which ones are the important ones to solve the problem that you're trying to do. So for example, in a lab space, we don't have a manufacturing line to do a digital twin of it. We don't have a rocket to be able to do a digital twin. So what we try to do in the lab to try to test some theories out, let's say in our lab we have a 3D printing, and we want to be able to create that digital twin of a 3D printing. So we want to see in a computer what's happening in real time, but we want to also make it know what's going on and behave and understand the data that is flowing to it. So you can, let's say we were getting an attack to it, so we can stop, or the temperature of the nozzle is going too crazy outside of the numbers that I'm expecting. So it knows when that happens, and it can push a command to stop the printing and prevent those things to happen. But when you're verifying and validating and to seeing if that is behaving how it's supposed to behave, it's a difficult task, because now which are the variables? So let's say you're doing the 3D printing, so you want to get the speed. Let's verify and validate the speed of the nozzle, the movement of the nozzle. We can get the temperature to make sure the printing behavior is correct. We can get the height of the printing and the table, and other variables, but then those information are already provided in printing softwares. So we double check. We make sure that it is happening. It is, verification, validation. It is first, it's happening the way it's supposed to be, and second, it's happening the way the environment needs it to be. It's behaving as expected, and now it's behaving as I thought it would be expecting. So, and when you put the AI in there, that is also collecting and making those decisions to help you make those decisions. So there's several research questions there to how to even build trust on those verification and validations. So one way to go about it that I've been working on with some other colleagues is using the classic digital, the V systems that for systems engineering is going from the requirements to the delivered. So how do we go and verify and validate from the requirements that we have of which variables do we need to, that we want to have in that digital twin to achieve and solve that problem specifically. So you know which ones you need to always be constantly verifying and validating as you progress in the levels of capabilities of that digital twin. Because you can't just create it and let it be, because it needs to be constantly changing and moving, because it's a dynamic environment. So how do we build that framework and structure to do that for us? So that's some of the research that we are doing that too.
Thank you, Lisa. Thank you, Anna. I'm sorry. Now, I think this is a good discussion, but I want to open the floor to questions. This is an open question for everybody in the panel. How can we make sure to establish the right kind of metrics and benchmarks when you're evaluating human AI systems? And at the same time, how can we ensure that these metrics that we design are aligned towards scientific goals and societal ethics, as we like to call it? So it's open for the panel.
Well, one thing that comes to my mind first, Vineetha, when you talk about that is something that's come up periodically throughout our conversation here today, and that's the difference between normative and descriptive decision making. right? So we have some expectation for how a system is going to work that's optimized based on how that system was designed, based on the performance metrics that we have for it. And we have some idea of how people are going to use it. And then, of course, people come into the equation and they begin to behave descriptively, not normatively, which optimizes outcomes, but in whatever way they want to. And they do all kinds of crazy things, right? So when I think about how we build these models and how we develop these metrics, I'm always thinking about who the user is. Who's the person who's going to be using our product, and how do we include them in our sample? Because I could come in as an expert and do some heuristic evaluation of this particular interface. But the things that I'm going to notice, knowing what I know about your product, are going to look very different than the challenges that users may encounter when interacting with that product. And I think as AI becomes more ubiquitous, it becomes increasingly important to consider that question. And, frankly, if I can just take a moment, that's something that keeps me up at night. Like, I'm very serious, right? So I'm a psychologist, on the one hand, like, I'm in the academy, we could do a lot of research in the lab, I could work with a lot of students. But that doesn't create results that are generalizable to the public. And that was a really big problem. I was like, how do I get more people in my studies? So this is gonna sound crazy, but we started sending people out when they were going on vacations. People would take a vacation someplace, and I was like, hey, here, take our survey with you, and please take some of these mugs so that you can give them to people who participate in your survey. So we were just out on vacation, like these researchers who would just go up to people, hi, I'm from the University of Alabama in Huntsville. Would you like to participate in a 15-minute survey about trust and automation? And we would just evaluate people in public places or get permission from people in private spaces to be able to collect this data from people. And in doing so, we created a model, in this case, that was more representative of what ordinary people were doing, thinking, and feeling about this particular system. So, not everybody is interested in a model that generalizes to the entire US population, right? And so you might not need to be going out everywhere that you can think of to collect your data. But, if your user consists of specifically astronauts, then, please don't collect data from students who are not currently astronauts and don't meet those criteria. And, likewise, if you have a particular broader sample, it's important to take that into consideration as well.
Yeah, nice answer, Lisa, and I'm glad I got your name right. Let me quickly add on to some of the really cool stuff that we've been doing at DevCom. I think we started this foundational research of how we can use explainability 3-4 years ago, and we went through quite a year of intensive lit review, understanding what people in psychology think, people in philosophy think, and we had a great panel the other day, computer science believe what AI is, and what explanation means, what ethical AI means, responsible AI, all these buzzwords, right? So in academia, we have a different idea of what it means and what particular requirements look like when we say, check, this is ethical AI, check, that's responsible AI, check, this is transparent. But when we look at it from the industry side and different sectors, be it NASA, be it the Army, DOE, DOD, they all have these super vague guidelines, about 5, 6, 7 bullet points, some even more, saying all of these abstract qualities mean explainability. That's great. But you're talking to designers at the end of the day, and I'm a facts and figures kind of person, like a nerd. Tell me what these abstraction means. Give me a designable 1, 2, 3 attributes. What does it actually mean to code it, right? If I'm having to code it, I cannot say, oh, it should be held accountable. Define accountability. It should be transparent. Define transparency. What do you actually want to see as a result of this attribute in the system, right? So that's where we started, and we realized quickly that this is a good question to ask because everybody thinks of it in different ways, but we have to bring in a common terminology, first of all, so that when I say transparency, it is the same thing as what you mean transparency is, or you expect transparency is, and the system has the attribute. Right? And one of the things that we did, starting with some of the explainability stuff we were designing at that point, was everybody have heard about LIME and CHAP and I guess CAMs, class activation maps, and a lot of other cool stuff. So yeah, we did start there, but we took it many steps ahead, and we are working with DevCom to clear that for publishing. So that's great. Explainability is great. You have these buzzwords. But when you want to implement in terms of physical system design, what does having LIME mean to your system? What are you evaluating? What is the operator getting out of it? And how can we derive information content saying, LIME is explaining this. It means that it is validating 80% of the identification, 90% of the information. What is it actually explaining? And from a designer perspective, from computer science, what I'm looking at is different from what systems engineer is looking at, is different from what psychology is looking at. So when I design the system, I might not be the end user. Somebody else in this chain is going to be the end user, right? So what we also came up with is really fascinating. I really urge you guys to keep a tabs on what we're doing. We'll be releasing that journal paper for publishing soon, so keep a tabs on that. We came up with an interpretability score, an explainability score, to help the designers exactly with that process. So we decided to move from the abstractions of, this is what explainability means, it should check mark security, privacy. Well, okay, as a designer, let's say, what does it mean for me? I'm interested in a system that is transparent, that's explainable, that is fair, let's say that's privacy enhanced, or that's robust. I want to make sure I evaluate my system based on my specific design criteria. Because at the end of the day, that's what explainability is. Is it explaining me? Is it satisfying my requirements, my constraints, and serving the purpose I desire? And that's exactly what we did with the score. We said, okay, this is what AI is doing. Now let's add a layer of explainability to it. Now let's add the layer of your own system requirements as an additional layer. Evaluate all of them to help you understand where the human AI teaming performance is going to look like. Is it desirable to what you're expecting? If not, let's go around and play with the individual components and make the change in the design so it actually suits you. So it's your purpose. And therefore, we wanted to put the power back in the hands of our soldiers, designers, the algorithmic experts, data scientists, data engineers, and say, hey, let's give you this evaluation format so that you can take what you need and take what AI is telling you, take what the human being is telling you, take what the system requirements are, and see if your design actually meets the requirements of explainability and transparency that you desire. So that's some of the things that we have considered when we are designing metrics to make sure it accommodates everybody in the loop, everybody in the conversation, everybody in the chain. And it's, I think, a good way to look at it in terms of the end users. So now I want to kind of go into the last form of the panel and open the question to ethics, because I heard that the last panel had a lot of discussion on trust, so I want to wrap it up with ethics, right? So we are dealing with humans and AI. That's a lot of conflict right there, right? Who is right, who is wrong? How do we bring everybody on the same team? So how can we ensure that AI and human systems research is conducted in a responsible and ethical manner, and that AI systems benefit equitably across the society? Howard?
This is a hard question. For example, if you think about wearable sensors, your wearable heart rate monitors, especially if you hear about earlier generation ones, they don't work that great in dark-skinned people, for example. People with darker skins, are more difficult to be seen by, by your machine learning-based, detection algorithms, for example. So, thinking about the data sets that we use to train our algorithms? Is it reflective about society? Are we, inadvertently biasing our data somehow based on what we use to train it? And so, for example, if all of your data is used to train, African Americans on, something, crime related, like, is it inadvertently biasing your results in terms of what it could do? We think that an AI-based system, in theory, should not have any bias, but in reality is, the AI-based system is going to make judgment calls based on the data that it has. So if the underlying data has some type of a bias, whether implicit or explicit bias, then your model would also reflect that.
Very great, Howard. In fact, yesterday in my talk, I kind of talked over different kinds of biases. That's one of the things that, at least from computer science, we have to be aware of. There's obviously the data or sampling bias that trickles in. So if your data is going to be biased, you train algorithms on the biased data, you're going to get wrong results, right? And there's also things such as confirmation bias, societal bias. So like Howard mentioned, and I think Langley mentioned earlier on about the facial detection algorithms, right? So they're great now, they're everywhere, but at the same time, we want to know what is the accuracy of it? How is it designed? Is it really trained across the right kind of data sets that is safe enough to be societally adopted? I worked on a face recognition technology 2 years ago, and we published a paper extensively discussing the algorithmic bias and confirmation bias and all kinds of biases. It was interesting during the design process. We were doing the right things. We were working with 2 open source data sets. We did the right kind of sampling, data augmentation to make sure we are addressing the bias. However, we were not seeing the equal amount of performance as we expected. We were doing everything right per book. And kudos to my student. So she took it another step, and we had 65,000 images in the data set. She actually went deep down to figure out what is happening in the bias perspective. Is it the algorithm that is really biased, which we have tried to take care of as many things as we could, or is the data really biased? Well, we found out that bias trickles in not just from data, algorithm, again, from the designer perspective. If I have a particular bias, that comes into the algorithm that I design, and also from the data labeling perspectives. Like I mentioned earlier, who does a lot of data labeling, especially the open source data sets by universities? Students do. Do they have the appropriate background and expertise to actually do that kind of job? Sometimes yes, and sometimes no, right? And especially face recognition technologies, if you're not acquainted with diversity and you're just doing a binary marking of black and white, of male versus female, and you don't know anything about in between, and you are just basing it on, let me see what I think this is, and I label this person as Latin American, Indian, or whatever, you're creating your own bias, human instigated bias that trickles into the data. Now that it is released to the public, being cited by a number of papers, it's everywhere. You've proliferated bias, because now a lot of algorithms are being designed on this. So we found out that a lot of issues start sometimes from the data labeling, and this is where domain experts need to be involved in every single chain. Starting from the data, can we have somebody overlook the data and say this is valid? Can we have somebody look at the design and look and make sure this is valid? And across the process to have a transparency, so you know where to go back and make the changes if and when you should. So with that, I'm going to close this panel, because I think we have a lot of things to talk about ethics, and open the floor to the audience. Any questions you would like us to answer?
Okay, we go. Thanks all of you for coming out. Nice to get to know you a little bit better. Haha. So I've got an interesting question. I think you've got a good mix on the panel for this. We know that we behave differently when we know we're being observed. So are there, game theoretic or other type of approaches that are being investigated to be able to overcome these types of behavior changes, or perhaps even optimize the response that the model would try to take in the face of these sorts of behavior changes?
Absolutely love the question. Lisa, would you like to take first from the psychological perspective, and I'll add from the computer science?
Yeah, sure, certainly. Yeah, that's an excellent question, and it's something that we as psychologists have been thinking about for a very long time, because if I'm going to ask you a bunch of personal questions about yourself, you're going to change your answers to those questions if you tell them to me as opposed to anyone else in your life. So one of the ways that my laboratory has worked to address this is through artificial environments. And, augmented reality is one of them, right? We've talked about, well, you might be familiar with the process of like flow or immersion, right? When you're like really into that video game, you like totally forget about everything else that's going on in life, and pretty soon 3.5 hours have passed and it's time to go to sleep, or you've forgotten to eat your lunch, right? Something like that has happened. And we can capitalize on environments like that to collect data that more accurately represents the way that people would act in environments where they aren't being watched. So within the context of my laboratory, that means performing tests within augmented reality settings. I also, this is going to sound crazy, but I became proficient in coding video games in Unity because I wanted to be able to study certain psychological phenomenon in a space where people thought they were playing a video game. So I have these little contexts where people are playing video games with the help of an autonomous teammate or without the help of the autonomous teammate, or they might be watching a human or watching an autonomous teammate. And an important question that we ask is, do people evaluate the human the same way that they evaluate that autonomous teammate or that artificially intelligent teammate? And the answer to that question, as far as my laboratory has studied it, is no. That's something that we refer to as the unique agent hypothesis, the idea that humans treat artificially intelligent or autonomous systems very differently than they treat their human teammates, and they look for different things when they make decisions about those systems relative to how they make decisions about humans. So it's not sufficient to put people into a context with human teammates and assume that that behavior will generalize to a different setting. We have to capture that data in that novel environment, which is where things like augmented reality or video game contexts or simulations become so important. So I think from the psychological perspective, that's how we might try to address some of those things. Obviously, if we could just be a fly on the wall and just collect data all the time, that'd be great. But to your point about ethics, Vineetha, that's incredibly unethical, right? As psychologists, we uphold 3 ethical principles, and this is all human subjects research. We want to optimize beneficence and minimize maleficence. That means that we try to create studies that are going to help humans, not harm them, and study things that help humans and not harm them. We also prioritize respect for persons, so we make sure that the people who are involved in our research studies aren't unduly impacted by being involved in those studies. And we also focus on anonymity and confidentiality, making sure that the people who provide us with their data are not going to, in some way, be inadvertently tied to that data. And I can think of a couple of unique situations where that might not be true, like if you're creating a digital twin of a very specific person in a specific context, you do need data that's coming from that individual person. But the way that we would address that principle of anonymity and confidentiality looks a little bit different in that context, as opposed to if we're collecting data from many people.
And before I address this from computer science perspective, I just want to add a short discussion that I gathered from a keynote talk. It was about a project funded by DARPA on human AI stuff, psychology, especially relating to both, Greg, your question, and also what Lisa was talking about on how human and human interact versus human AI interact, and different formats of human and AI. This was a great takeaway for me, so I think it will be amusing for you as well. So in this study, basically they teamed humans with different AI agents, and they had automated voice agents like you would have for your Siri or Alexa. So that's one automated voice, right? Saying, hey, Alexa, Siri, help me do something. And then they had agents such as small virtual reality, small pets like a puppy dog trying to jump around and give you helps and hints on how to solve this task in mission. So that was your cheat code agent that will help you. And then they wanted to, well, basically understanding the perception psychology behind human agents and how that's going to impact our decision making. And then they had another level of improvement on the agents, and they had somebody who was like a tiny avatar sitting on the table, sitting on your shoulder, the cute little anime character talking to you, and you could ask for help from this agent. Finally, you had a full-blown human version, like a teammate, a buddy in front of you, like a human sitting across the table, and you could ask help from the agent. Who do you think was the best buddy?
Dog.
Pokemon dog? Okay, that was a great answer. So actually, they really liked the dog, but they did not trust what the dog said. So this is again about biased perception of how humans interact with AI. And they actually found that they trusted Alexa better than the puppy dog. And they would rather listen to Alexa or Siri, where they could not see the face, the robotic, they would listen to the robotic voice, not see the face, rather than look at this cute little puppy dog, which was great to play with. I mean, it was cute when it said, you know, walk here or walk there or do this or do that. But they would not want to trust an AI that looked like a puppy dog because it seemed like, how can you be smart? What do you think was the next favorite thing that they liked? The human, the full-blown version human? The small human, that's the right answer, the small human. Because a small human seemed quite nice and friendly, like a nice buddy you can talk to and be comfortable and have a chat with. But the big human, apparently, a lot of people found them as intimidating, like somebody who is sitting in front of you and being judgmental about your mistakes. So they did not want to ask this big human, full-blown human, any help because they were like, you're judging me. You're judging me for my mistakes. Like, you're too big and you're looking at my face. I don't like it. Interesting, wasn't it? So I thought this would be a perfect way to look at how human and humans, you know, talk to each other, evaluate and relate to each other, versus how human and AI, you would think, would evaluate and relate to each other. Coming back to your question, Greg, I want to address it from the automation bias perspective. So I think one of the key points as a designer that I would want to look for is behaviors with respect to automation bias. That is how comfortable I am in using the technology. Because if I'm comfortable, I'll game the technology. Right? It's called gaming the system. How well do you know the system to game the system? So if you're talking to younger generation, they know the ins and outs of technology, and they would be more likely looking at technology in a way, well, this sounds nice, but I don't want you to know my behaviors, and I'm going to do whatever I want in this particular space, either conform to your directions or try to game the system. But if I'm not comfortable with using the technology, then I can see it in the interactions and my behaviors and patterns, which you've seen in a lot of the human system, human AI teaming interactions. I would be hesitant in interacting with the system, or I would take longer periods in interacting with the system, or I would pause and decide and then go back. And usually you see it where at the end of this mission, you have a dragged on time or a long interval or pause between the way you communicate or interact with this AI system. Versus if somebody's gaming the system, you can see it being more frequent compared to the other patterns. So in a group, there are still ways where you can work with psychologists and say, hey, I think I know what you're doing, right? But again, it is not something we can evaluate on a system level alone. This is exactly where we have to understand how humans and humans talk and work with is going to be different from having a human and AI buddy. So I'll close my answer with that. Any other questions?
Yes, ma'am. Within the physical security and public safety space, one of the targets has always been to, through CCTV or camera systems, active shooter detection, right? Anything that we can get further out from the facility, seeing these folks coming in, whether we do scene recognition or weapon detection, obviously harder, they're smaller, can be concealed. But recently seeing a lot of traffic regarding intent to do violence through muscular skeletal detection. Have you had any experience with that? And if you have, what are you seeing? Is it viable? You know.
That's a really good question. Howard, do you want to take a dig at it before I go?
It's a great question. It's certainly something that, I mean, is useful beyond what you're talking about. From the perspective of autonomous vehicles, for example, is can an autonomous vehicle recognize, based on motion patterns, whether a person is inadvertently going across the street or not? I think there is obviously some implications in terms of ethics, but beyond that is, well, how are you going to get all the data sets needed to train this? And, you know, how well is it going to work? How much data do you need, I mean, to classify that someone is, suppose you have a trained model, right? How much data do I need to say, okay, like this person is indeed going to be doing something? You know, like if is a gun drawn out and pointing at a person, is that the point where this AI is saying, yeah, something bad is going to happen? Or is it like, well, this person is reaching into a pocket? So I think there's also some interesting questions in terms of, well, once you have this AI trained to do this, how much data do you need to discern it?
So I'll start off with the autonomous system background, because I think when Tesla first started running, the pedestrian intent, right? Is this person going to jump in front of your vehicle or not? What is happening was a huge concern. And back then, there was a lot of research being done for exactly the same. So what is the distance between the vehicle? What is the distance between you and the pedestrian, for example, that is detected? Are you being in the attention mode or distracted mode? Are you looking straight, being focused, or are you looking down? Are your eyes down? And that has led to a lot of advancements that we see in the autonomous system now. For example, you know, when you take your hands off the wheel, you have a buzz and it says, hey, you have to focus, right? So there have been some design modifications based on the intent that's been observed in the environment. But to address your question directly, I had a long chat with DETRA officers for a couple of years now, and they brought some really interesting innovation in this domain. One of them was identifying malicious intent when people are loitering behind, you know, public defense properties. So you have CCD cameras looking at them, and they were making decisions based on how long is this person standing? Is it simply somebody willing to park, you know, be it parking lot, right? Are you just simply standing? Are you talking? And are you walking back and forth in front of the camera? Are you reaching into your pocket? So they have softwares. In fact, there is a lot of research going on into trying to identify the first intent, which is basically reaching into your pocket. It could look like, you know, maybe opening the door or watching somebody else in the parking lot, right? Like stalking, for example. Which direction are they looking? Where are they looking? To guessing if there is a potential probability of this turning into, let's say, trying to break into a building, trying to harm somebody in the parking lot, and if we can alert, say, 911. So there are active projects going on in DETRA, as far as I know, where they're looking at the intent of the human, how long, what is the interaction with the environment, and what kind of environment they're placed in to identify threats, because that's what they do, Defense Threat Reduction Agency. I don't know if DARPA is doing something like that, but there are some other universities kind of combining what basically we've been talking about all along. Let's look at the identification from computer science, let's add the motion graphics into this, let's add the intent part of the human, and if we add all of these explanations, that's where the power of big data comes into play, because you're not looking at it from one myopic perspective. You're looking at these beautiful pieces of puzzle coming together and explaining a story that is going to help you understand the way the situation might evolve and probably highlight the right kind of authorities to de-escalate the situation.
Thank you.
You're welcome.
Thank you all for the session this afternoon. I had a question. We've heard a lot of discussion about biases in collecting, you know, a lot of data. And you know, my initial thought would be more data, more bias. And the reality is, in society, we do have biases. They exist, and it's hard to kind of wring those out. So the real question is, as you kind of talked a little bit about, was who's kind of at the grassroots of this data collecting that is making really decisions that have larger impacts on the end state. What processes have you found in your research to wring out biases and processes on the front end, I guess, or upstream that you're trying to do to, at the end state, you still reflect all the normal aspects of society, but you've like somewhere, I guess, you grade this data to make sure that it's some level of acceptable bias, because it seemed like it's impossible to wring out all biases.
That's a very good question, and I think this goes back to what I was talking regarding the algorithmic bias work that we did, and honest to God, we were shocked to find that people were using these open source data sets for training, facial recognition applications. And again, today we have facial recognition everywhere, and God knows what they've been trained on, and yet we are asked to trust it and do the right thing. And I remember, I think it was 3 years ago, the first time I encountered the facial recognition technology was when I was coming back from a cruise vacation. And at that point, it was pretty nascent. It was not inclusive, is the best way to put it. Societally, we would want a technology that's been adopted to be friendly to everybody, because my grandfather was on a wheelchair, right? And they had not considered that, and they had the camera faced up. So he had to stand up and move back and do XYZ motions so that his face would align with the camera, and then his face would be detected. And luckily, they also had a slot which says, hey, fail-safe measure, you can always scan your passport. But that is exactly where, as the society and designers, we need to sit together and decide, what kind of impact is this technology going to have in the future? If it's going to be a societal application, what can I do to make sure that there are no blind spots? And if there are, how can I minimize and alleviate and have some other options to support, right? How can it be more inclusive, like facial recognition? It's not always disability friendly. Now, of course, it's much better than back then, because my grandfather literally had to stand up, sit down, move back, move forward. It was not designed for that. And some of the other measures that we have done, especially while we went through this whole process of the facial recognition technology project, was look into it from the data set and find different ways. In fact, we've coined different metrics and measures inspired by the project on how to identify bias in the data, in the algorithm, even after sampling, even after data augmentation. We came up with so many different ways, both post and pre-evaluative measures, which can help you identify, hey, this whatever technology you're implementing has an algorithmic bias or data bias, quantify it and highlight it saying you need to do something, right? So if this bias score is below a particular or above a particular threshold, which means you do want to address this issue before this rolls out into society. And most importantly, this is where we also want people from different walks of life saying, let's not just look at it from the computer science perspective, let's talk about it from inclusivity, let's talk about it from the point of diversity, from data labeling to designing to what the society believes this software should look like, the bias should look like in the society you're eliminating. Again, there's no way to bring it out. How can we minimize and eliminate, and at the same time create awareness that there is still a possibility of bias in the system, and make sure that the users are aware of it and not blindly trust the decision made by the AI before acting on it, right? So have some second, third evaluations, some more checkpoints in place, be it policy. And that's, again, what makes ethical AI different and really great, because by ethical AI, we're saying we're not just holding the AI accountable to its decisions. The AI is required to satisfy a checklist, a policy of requirements based on what we want it to accomplish. That helps us hold the AI accountable and say that it is doing what it's designed for, or if it's not checking all my checklists, then it's not compliant, and therefore I need to do something about it before it rolls out into society.
One place where I want to take this question is to the space of the human subjects research, which I think is a place where we don't often think about bias occurring in the development of AI technology. but I'm reminded of a conversation that I was having with someone from the military. They were talking about designing various different systems. And I was trying to talk to this person about what sample we should collect for the data, and they said, oh, we're going to be trying to use the system with people who are straight out of high school. Because if you think about most people who are recruited into the military, these are people who, a portion of them have a high school education, and they go into the military either concurrently with going to college or separately. They choose to go into the military instead of going to college. And one of the things that it's, I think, hard for some of us as designers to recognize, and it's certainly hard for me to recognize as the instructor of, 7 PhD statistics courses in my department, is that many members of the general public can't read a graph. And that creates some challenges when one of the ways that we tend to try to make AI more explainable is by illustrating the way that it makes its decisions using various graphs. And so there's probably some portions of the population who will struggle to read that kind of XAI. And that's one of the projects that my laboratory is working on right now, is trying to look at the different explainable AI techniques and trying to figure out which populations of people they work for. So that if you need to create some kind of a system, well, which XAI technique is appropriate, not just based on how, the kind of information you want to present, but who you're presenting that information to. So if we can come up with answers to those questions, we can expedite the design process, and instead of having to test every system, we can begin to issue recommendations for how XAI should work. And so, in the context of human factors, some of the things that Vineetha and I are talking about, we talk about these as the principles of universal design. Because if we create a system that depicts or makes AI explainable in a way that is understandable or comprehensible to everyone, well, everyone can understand it. If you're a person who understands graphs, that's great. You understand the system. And then if you're someone who doesn't understand graphs, you also understand the system as well. And it does take that extra step. It requires us to be more intentional about how we're designing systems and how we think about the people who use them. But we're also kind of future-proofing our systems. We know that they can be understood by many different kinds of people under many different kinds of contexts. So if you enter some off-nominal scenario where someone's got really high workload, or you've lost access to the person who usually interprets this particular part of your system, that no longer matters, because you have a product that can be understood by anyone.
Yeah, and to add on to what Lisa was saying, and to the expertise that we have in the panel, some of the things that is unique to what we do is that our expertise extends beyond this. So I think some of you have heard about philosophy and how that makes a lot of sense when you think about bias, and we also have legal experts as our collaborators. So we look at bias as a societal problem from different aspects, from computer science, psychology, systems, legal, philosophy, to make sure we are tackling the problem in a more holistic manner and not just wringing out a software for the sake of it, a product for the sake of it, and that it actually benefits the society as a whole.
Thanks for your patience with me. So, we hear a lot about, we live in times of, we're divided like never before. You hear about divisions between the sexes, the genders, the races, different ethnic groups, whatever, but to tie it back to AI, we begin with there's a diminished trust in AI. The political left tends to have a distrust for the profit-seeking enterprises that would build certain systems. Political right is going to have some diminished trust in regulators that would try to set policy around these things. So you've got not just broad mistrust, but lots of layers of it. How in the world would we even begin to navigate a system like that? So, you start with just it's unfamiliar technology, but then you've got all these other factors that are weighing in there as well. How in the world do you navigate through all that?
Wow. That's that's quite the question. So in psychology language, the word that we would use to refer to that is individual differences. And I keep bringing up all these little terms and peppering these in here, and part of the reason that I do that is because I think that oftentimes we're studying and thinking about similar things, but we're just talking past each other. And I know that if I start drawing these connections between things, if you want to go home and Google up more about how we do this and what we know about it, some of the terms that you could use in addition to the ones that you might think about yourself. So from human factors, from psychology, we think about individual differences in people's trust in automation or in people's trust in artificial intelligence. And I think that earlier in our understanding of this, we were studying factors that were more relevant given that time period, right? So I think about like the rise of the computer, the rise of artificial intelligence. And at that time, people were talking about and thinking about how does age impact how people trust systems, right? Because they were like, oh my gosh, we've got to get people to use these smartphones, and younger people seem perfectly willing to use them and older people don't, right? And so why is that, and how do we understand that? But as we've learned more about individual differences, we've come to understand that age or political leanings or gender or any of these other variables in and of themselves, we can use to index things like how much people trust the system. But as psychologists, we're thinking about what is that variable a proxy for? So when I think about age, it's like, yeah, older people generally don't adopt technology as readily as younger people do, but that's not because older people are boomers and they don't understand the technology, right? That's like a prejudicial attitude that I could hold about older people. It's because older people probably have, if I had to imagine this as a person who's aging myself, it's like I become very structured in how I go about things. And there are certain technologies that I've been using with which I'm very proficient, and I like to continue to use those technologies because I understand how they work. I know what kind of information they're going to produce for me. There's nothing unusual about my interactions with them. I have a good mental model for what that's going to look like. Now, a younger person has no existing mental model. So picking up something and figuring out how it works and learning about it happens pretty readily. So, how do we grapple with all of these factors? How do we understand them? There's literature that's out there looking at factors that impact things like trust in automation or use, and we could talk about like the technology acceptance model is a very common model of how people accept technologies, that we weigh the benefits and the risks of using a technology. If we perceive it as being more beneficial, then we perceive it as being risky, we'll adopt that technology more readily. And what those risks and benefits look like differ across people, such as older adults and younger adults weighing their willingness to adopt certain technologies. But we can also think about factors like, relating to models of trust and automation. Like there are not only these individual difference variables that impact trust and automation, but we're also talking about learned factors. So some degree of older adults' reticence towards using technologies is something related to the variable of age. But some of it is also related to the fact that they don't have many experiences with these systems, and they have many experiences with other kinds of systems. And that also impacts their willingness to adopt that technology. So I think when we're asking these kinds of questions, it's very important not only to take into consideration which individual differences are we interested in, but also what other behavioral or environmental variables might they be correlated with that may be driving that relationship. Because I can't change whether someone is older or younger or what side of the political divide they lay on. But if I figure out what underlying characteristic is correlated with that individual difference variable, now I have some information about how I can make a product or technology more useful to them or why someone is more reticent to use it.
Great answer, Lisa. So I'm loving your questions this evening, Greg. So let me start off with saying AI has no religion. Humans do have bias, and therefore it is our bias that trickles into designing these systems. A perfect example of sweating left or right is going to be Cambridge Analytica. It's just data. There was no religion, there was no left or right involved, but yet it was this powerful data in the hands of biased humans who took advantage of it to sway the human emotions, either left or right, however you want it to be swayed, right? So at the end of the day, it is how we use the technology that dictates the social impact that it has. And how can we address that and make sure there is not misuse and improve the trust or the distrust in technology? Well, that's where I want to go back to the transparency and ethics and the explainable side of AI. How can I add layers of information that can help you understand why the AI made the decision as it did, so you, as a cognitively informed human being, can use your own intelligence and make the decisions that's right for you, what you think is right. Don't let the AI tell you what is right or wrong. Let the AI tell you why the decision or suggestion or recommendation was made, right? And let's leave the decision making to humans, right? We are autonomous beings ourselves. So let's start there. And then let's look at how these technologies can actually help us leverage our daily wellness, productivity, and well-being, and so on. So when you work with these technologies, for example, ChatGPT, I would not have thought about asking ChatGPT to organize meetings on my shopping list or so on, and somebody in the university was like, I have a meeting, I have to do it for the provost, and I'm going to ask ChatGPT based on everybody's allergies what kind of food I should order for the table. And I thought, wow, as a computer scientist, that would not have been my first use case, right? So this is where as we start interacting with these technologies more, get familiar, understand what they're doing, and see that this is beneficial, it's helping me to organize some part of my life in one way or the other, we can start unraveling those trust issues and hopefully have improvements in adoptions as we go forward. At the end of the day, technology is here to assist us in making our lives better. And let's hope that that's what we want to use it for rather than any misuse of technology.